impact strength will increase, elongation will increase, along with dimensional stability. Now, these are just generalizations, of course, and are dependent on the material that you're looking at. But one important thing to note is that crystallinity can also be further controlled to some extent during the molding process. This means that when you dial in a molding process for a part in a material, once that's been optimally defined, it needs to be tightly controlled as well to ensure that the same crystallinity is maintained from lots of parts to parts. Other things that can be used to modify the polymer properties, just besides its general traits, whether it's amorphous or semi-crystalline, is the addition of additives. Additives would include plasticizers, which will make the material more flexible, flame retardants, which will obviously improve the flammability of the material. Flame retardants, the majority of them today are made from aluminum trihydrate, phosphorus base, halogenated, or antium oxide type materials. It's important to note that additives may have a secondary effect on the behavior of the polymer. For example, in the case of the flame retardant, as you can see in this table, the flame retardant packages basically result in an unexpected property change. You can see as the flame retardant material increases from unfilled to a B2, which is a very high-rated material, and a V0 as well, you can see how the tensile strength is affected, as well as the modulus and the impact strength. So it's important to note that when selecting a material, that you try out and understand the properties of the material that you're using, not that you choose for example, like a polycarbonate material, and you go back and you want to get it flame retardant. You got to understand that the properties could change as well, and those need to be considered. Some additional additives are stabilizers,